Wishing you a very good day. Today we are here to talk about some vulnerabilities we have found from an application and the fixes we have done to overcome those vulnerabilities. So I'm Economical JSMR and WIU. So these are the vulnerabilities we are going to talk today. So the first one is security misconfiguration. So in cybersecurity, security misconfiguration refers to the incomplete implementation of security settings within a web application. So these misconfigurations can create a domino effect. So what happened basically is the attacker always continuously search for the internet for vulnerabilities. So if they found one, they can take the advantage from that easily. So by addressing these security misconfigurations, we are not only safeguard our applications, but also we are protecting our users sensitive data, ensuring a safer online experience for everyone. So the project I have taken into consideration has security misconfigurations. As you can see here, the save appointment request that is developed by Express.js, there are no validation for inputs or middleware, so which will lead to security misconfigurations. So this is the code after fixing the vulnerability. So for that, I have got Express validator. So it is used to check the title and the PNAME is not empty and the mobile is in the correct format and like so. So the validate middleware is used to handle validation errors. So not only in the post request, but also in the get request, update request, and delete request, almost it's the same, which means each and every endpoint includes validation to ensure that the required fields are present and have valid values. So the next vulnerability I have found is XSS attack. So XSS stands for cross-site scripting, which is a type of web security vulnerability that allows attackers to inject malicious script into web pages viewed by the users. So if the application has a potential for XSS attack, several harmful consequences can be happen like data theft, session hijacking, phishing, and account takeovers. So to prevent XSS attack, as developers, we should validate and sanitize user inputs, and most importantly, we need to educate our users about safe browsing habits. So in the project create a booking.js file, there are no citation or validation for the user inputs, which leads to XSS attack. So in this code, .purify.sanitize is used to sanitize the data first, but first we need the .purify library. So in here, I have used .purify.sanitize to sanitize the data before rendering it. So after that, this is the part where I have eliminated the vulnerability by sanitizing data by using dangerously set in a HTML attribute. So by using the previous mentioned .purify.sanitize and this dangerously set in a HTML together, we can mitigate the risk of XSS attack. So here I have tried to insert XSS attack using a script tag. So as you can see, it is only displaying as a plain text, so no harm will be happen. So moving on, I have added Google login as a new feature using auth server. So in here I have created a client for logging, and here after successfully logging to the system using a Google account, the encoded JWT token will be generated. So this is the decoded JWT token, which includes email, expiry date, like so some details. So yeah, that's basically it. Let's move on with the next vulnerability.
The first vulnerability I have found is broken access control. What is broken access control? It is a security vulnerability that occurs when an application or system fails to enforce proper access restriction on users. From this, it allows unauthorized individuals to access privileged resources or perform actions. This can result in unauthorized data exposure, tempering, or manipulation. So that preventing broken access control involves implementing strong access controls, authentications, and authorization mechanism to ensure that users can only access the resources and perform actions that are appropriate for them. This project is consist of broken access control vulnerability. These are the screenshots that show the places where the broken access control vulnerability is active. This is the update code after I have fixed the vulnerability. Here I have used async to reduce callback hell and also error handling to catch and respond to errors gracefully. Here's also I have used a way to handle asynchronous operations more cleanly, as well as the comments are used to improve readability. In this code, I have added the space after barrier in the token response to conform to the standard barrier token format. Furthermore, I have used to string with units for token expiration for better readability. The next vulnerability I found in the project is command injection. A command injection vulnerability is a critical security flaw that occurs when an application allows untrusted user input to be directly executed as a command. Attackers can feed this vulnerability to run random system commands, potentially gaining unauthorized access, manipulate data, or causing system damage. So, by using proper input validation, sanitation, and carefully handling of user granted data are crucial to mitigate the risk of command injection attacks. This is the code part that I have found with the command injection vulnerability. To mitigate the vulnerability, I have removed the potential for command injection by directly using user input in MongoDB queries. And in here also I have enhanced error handling by sending error messages. Here I have added this option when updating to return the update document in the response. Moving on, I have added the Facebook login as a new feature using the auth server. This is a screenshot for it, and this is the app ID I use for my implementation. This is the access token after generated.
I am Agapattu HMCP and my ID number is ID 2025-2090. I explain identification and authentication areas. Code update for improve user authentication and error handling. In the React application, we have made create environment to the user authentication and error handling policy to provide a better user experience. Here are the key updates. Introducing generic error state variable. Improve component bit update lifecycle method. Enhance style with last name utility. These updates collectively contribute to more effects and user-friendly authentication and error handling system in the React application. So this is the previous code. This is the fixed code. I need to next vulnerable and outlay component introduction. In our Node.js application, maintaining the security, visibility, and functionality of our software system is promoted. One critical effect of achieving this addressing vulnerability and outdated component list in our package.json file. This update not only migrate normal security risk, but it also ensure compatibility with involving and the latest factors and improvements within these ethical components. How this works is also the interior of our application. So first, JSON web token update. The JSON web token update. The JSON web token package play provide role in web application security by enable the influence of JSON web token for user authentication. The old version I update to latest version 9.0.2. So next I update Mongoose. The Mongoose package serves as a critical between Node.js applications and MongoDB database. Data integration and MongoDB. The old version I update to 6.12.0. So next, passport update. Passport is the Adobe authentication middleware for Node.js application, offering support for various authentication systems. So I update 0.41 always to 0.6.0. So last I update validator update. The validator package is implementing in the security and visibility of web application by editing and input validate. So the old version I update to 13.11.0. So I can show the previous package JSON and I right side we can see update package JSON.
Let's see what is server-side request forgery. Server-side request forgery is in cybersecurity when an attacker manipulates a server into making an unintended HTTP request. As we can see in the diagram, the attacker is making a malicious request, and also the response, the attacker is getting sensitive data of the application. So, let's see how to prevent these attacks. To prevent, we can use input validation, whitelisting, and keeping the libraries update. So in here, I have used input validation and centralization. This is the previous code, which is affected by the server-side request forgery. And I have added the validation, and now it is secure. And we see another vulnerability security login and monitoring features. So this is essential for debugging, auditing, and forensics. This is, these practices are very useful when it comes to low problems and for debugging also. So let's see how to prevent these things. So in here I have there is no login in the code. So in the next one, in the updated one, you can see there's I have also the errors. in here, and we can see what was the error that was happened, and if the application is studying AWS or Azure, we can see the logs from the cloud. In AWS, we can use the cloud voice. Yeah, that's also my thought. Thank you.